Greetings everyone. Today we're going to explore solving systems of equations, specifically by substitution. Make sure you have your notes handout for this. It'll make it easier, but you could also write it on your own paper. The first thing I want to do is just to talk a little bit about the word substitution. You have substituted in the past, so you don't need to jot this down. But just a refresher, if I told you x was equal to 2, and then I gave you the equation 3x plus 6 equals y. And I said, please substitute the x in and solve for y. So what you've done in the past is you put parentheses, right, or some type of openness, and you substituted the 2 in for x. You replaced it is another way to think of it. And then you took care of whatever calculations you could take care of to find whatever you were trying to find. So this idea of taking a value and plugging it in to a blank spot or replacing it for a variable. We're going to do the same thing today. And just a quick little preview. The difference today is all we're going to do is I'm going to extend this value. Maybe it's going to say 2y plus 3, right? It's going to be an expression instead of a number. So you're still going to throw in a 2y plus 3, right? Whatever you have, you're still going to substitute it in. So you know the process. It's just we're going to have an expression instead of a number. All right, let's take a look at this first example. Now, if I asked you, and here's where it's your choice, to isolate a variable, which one would you choose? There's a bit of a strategy here. It doesn't matter which one you choose, but I'm going to pick the one that's almost already by itself, right? Look at this y here. That y is almost by itself. If I want to solve for that y, I'm just going to add 3x over. I just isolated y in one step, right? That's much easier. There's no fractions, anything like that. The next thing we're going to do is I want to substitute that expression into the other equation. Can't plug it back into itself because that would just cycle around and get you nowhere. We want to substitute it into the other equation. Well, let's see. If it's equal to y, I want to replace the y. So watch what I'm going to do here. I'm going to take this first equation. I'm going to write it, but wherever there's a y, I'm going to put a parenthesis. Or maybe you want to put a box or a line, but we need a gap in there. So see how I replaced that or left a blank for that? So I want this y to be substituted. Substituted by what? The entire expression. So I'm going to take what I found from my work and substitute it into the other equation. All right, that's right there. That right there is the new big step. That's it. Everything else we're doing is going to be review. So that one step is where you need to slow down and think about it. Because from here, you guys, I'm just solving an equation. So I have parentheses. Let's distribute that. Bring everything else down. Remember how I drew a line when we solved equations? I'm going to do that again. I'm going to combine like terms. Let's see what else. I'm going to kick that 32 to the other side. So I've got a negative 20. Oh, easy, perfect. So I'm going to divide by 20, and I got x equals negative 1. Awesome. Our answers are still the same as our solving by graphing in the sense that I'm going to have a point. And so far, my x is negative 1. Well, now I need to find y. And this should be the easier part. You get to substitute negative 1 into any equation, right? You could pick the top one or the bottom one. Doesn't matter. I'm going to pick the bottom one. Do you know why? I'm going to pick the bottom one because it looks smaller. That's really the only reason. So instead of x, I'm going to plug in a negative 1. See how I did that? Instead of this x, I plugged in a -1. All right, let's calculate. Now we're just doing some easy solving. -3 times -1 is 3. I want to subtract 3 from both sides. So y equals 5. So my y value is 5. So we're bringing back the entire first unit of solving equations with this one new step. All right, let's try this process again. So my first goal is I need to isolate a variable and I get to choose. There's 4 options. See the 4 variables? Which one looks the easiest to isolate? I think that y, because if I want to isolate the y, all I need to do is add x over, and I end up with y equals 3 plus x. Well, that was easy, right? Make it as easy as possible. You have options here. Now let's take care of that new step. That new step is I need to plug what I just found into the other equation. And where am I going to plug it in? Well, we just solved for y, so I want to plug it in for y. Don't plug it back into itself. That's not going to work. So here's what I'm going to do. I'm going to take equation 1. I'm going to write it. But where there's a y, I put a big gap. Right? And where there's a big gap, I'm going to put the expression I just found. I need somewhere to put it, so I put it in for the letter. Every time you do this, you'll know if you're on the right track because look at my equation now. That equation is a bunch of x's and numbers. We can solve that. Don't call me after midnight. Remember that abbreviation? We're going to distribute first. And if you need help with this step, you're going to have to go back to Unit 1 videos. I'm going to combine like terms. Negative 3x plus 3x cancels. That's 0. So the 9 falls down and the 4 falls down. All my letters went away. Remember this? So I'm left with a question. Is 9 equal to 5? No, that is not, equal to 4. I know my numbers today, right? 9 is not equal to 4. This is our special answer. No solution. So when you have these unique answers, they're actually pretty quick problems sometimes. If it's not true, it's no solution. Let's try example 3. Same process. The first thing I want to do is isolate a variable. This x is already positive and by itself, so I'm going to solve for x, meaning I'm going to add y over. When I do that, the x falls down and I have 5 plus y. All right, this time I solved for x. Let's look at the other equation. See where there's an x? I'm going to write the first equation, but where there's an x, I'm going to put parenthesis. And where there's a parenthesis, I'm going to write my expression. That's the only new piece, you guys. That's the only tough part. If you don't think it's tough, awesome. If you do think it's tough, you got to slow down. Keep working on this, right? Notice how I'm making things bold or I'm boxing things. Maybe that would help. Let's solve the equation. This is old news. Distribution first. Combine like terms is next. Oh, positive 2 and negative 2 cancels. The 10 falls down and the 10 falls down. All my letters went away. Is it true or false? Does 10 equal to 10? It does. So what do you think my answer is going to be? That's right. Infinite many solutions. Same as solving by graphing. Same as when we solved equations in Unit 1. All right, let's try example 4. My first goal is I need a letter by itself. Yes, y is already by itself. Y is equal to 2x minus 3, so I get to skip that step. But my new step says, take that expression and plug it in to the other equation. Well, if it's equal to y, it's got to go in for y, so watch this. I'm going to write the equation, but where there's a y, I put parentheses. And where there's parentheses, I'm going to write my isolated expression. See that? I substituted it in. That's all that's new is right there. Next, we're just solving. If I was to distribute, it's a 1. So that would drop the parentheses. Combine like terms, 2x and positive 1x is 3x. The minus 3 falls down, 18 falls down. Let's add 3. That gets us to 21. Hey, and let's divide. Nice, clean answer of 7. So let's start prepping our answer. X is 7. Well, I got to find y. So here's your options. You can plug in 7 for x into the first or the second equation. It doesn't matter. And in this case, to be honest, they're the same amount of work. So I'm just going to pick the first one because it's first. Wherever there's an x, I put parentheses. Wherever the x would have been, I put the 7. Well, let's solve. 2 times 7 is 14. 14 minus 3 is 11. Y is 11. Now here's the thing, you guys. In that step of isolating a variable, let me give you a hint. If you go to isolate and you end up with crazy fractions in your very first step, you're probably making it harder on yourself. Like I would stop and I would pick a different variable to get by itself. That first step of isolating shouldn't be really messy or complicated. All right, this one is unique because both variables are isolated, right? So here's what I'm going to do. I'm going to say I want to use this y isolated and this is my expression. All right, now notice I'm putting boxes around it just to acknowledge, hey, that's my expression, which means I'm going to take the other equation, and where there's a y, I'm going to put a gap. I'm going to put parentheses. And where there's those parentheses, I'm going to put the expression. Now what you'll notice is we really just set each expression equal to each other in the end. It seems a little weird, but it's the same process as all the others, just looks different. That's our new step. Next, we're just going to solve, right? Well, the parentheses, technically there'd be a 1 out front, which would just drop the parentheses. There's no distributing now, there's no combining, so let's move a variable. Instead of minus 2x, let's add 2x. Oh, when I do that, they both go away. And these are the numbers that are left. Is 2 equal to negative 2? Nope, it is not. No, which means no solution is your answer. All right, let's take a look at the last example. And one thing I want to do here is I want to experiment a little bit here. So don't write this down, okay? What I want to show you is I'm going to solve for every variable. Because I want to show you sometimes there's a strategy. Sometimes if things get messy, you can change your mind and pick a different variable. Okay? So don't write this down. Just follow along for a moment. I'll let you know when to start writing. So let's say I want to solve for this x. All right, so I would add 4y over. I would divide everything by 6. Negative 10 6 would be negative 5/3. 4 6 would be 2/3. That's kind of messy, huh? Well, let's try a different letter. Let's say I was solving for the y. All right, negative 4y, I would minus 6x over. I'd divide everything by 4. That would be negative 5 halves minus 3 halves. Well, halves are nicer than thirds, let's be real, right? Thirds are irrational, halves are better. So far, this is a better option. Let's look at the second equation. Let's say I'm going to solve for this x. That would mean I'd add 2y over, divide everything by 3, negative 5/3 plus 2/3. So that one's kind of just as messy, right? Let's try solving for y on the second equation. So I would minus 3x over. I'd divide everything by -2. I'd get 5/2 plus 3/2, which is kind of similar to the purple one, right? Halves are better than thirds. But if you notice, these all have fractions. Sometimes that's going to happen. Sometimes if you get crazy fractions, you can stop and try a different equation, try a different variable. All right? What's going to happen, this is going to work out okay. We're going to have to deal with the fractions though. All right? So I am actually going to choose the thirds. I know, I'm going to choose the tougher one, okay? So I'm going to keep my red work. So at this moment, now I want you to start writing in your notes. We are going to take the first equation and solve for x, the red writing. I'm going to need some space for this. Okay, so first equation, we solved for x and we have this expression. Pause if you need to get that written down. Next, I'm going to take the second equation, the other one, and wherever there's an x, I'm going to put parentheses. So I'm going to rewrite it. But where there's an x, I put parentheses. All right, wherever there's parentheses, I'm going to put my expression, -5/3 plus 2/3 y. That's the only new piece here. That's it. The rest is old news. Let's solve our equation. First step is distribution. Look at what happens, you guys. 3 times -5/3. The 3's go away. And if you're not sure, you're welcome to use a calculator. 3 times 2/3 is just 2. So even though you might end up with crazy fractions, they might go away. So don't get worried, don't get confused, just slow down and follow the steps. Next step is combining like terms. Well, 2y minus 2y is 0. -5 falls down, -5 falls down. Is that true? Is -5 equal to -5? Yes. So we have infinite many solutions. All right, so one thing I want to do is I just want to summarize some steps here, okay? We did the same thing over and over again, so let's show that, all right? So the first thing we did is isolate a variable. And I'm going to say you choose. You got to choose, right? Next, we substituted the expression, and I used boxes, so I'm actually going to put a box around this. Substitute expression into other equation. Don't plug it into itself. That's not going to work. Plug it into the other equation. Once we did that, that was the new step. Remember, I kept saying new. Then we just solved, right? And then lastly, if needed, substitute number. I'm going to use pound symbol into either equation, right? Like if I found x equals 5, then I substituted that 5 into either equation to find my second value, and so we solved. All right. Now there's a lot of ways we can break down these steps. If you feel like this explanation is not as helpful, there are so many tutorials and lessons on YouTube, so feel free to check those out. But I would recommend pausing and jotting these steps down. You have some space on your foldable, or you could add it to your notebook, but you're definitely we're gonna refer to these quite a bit. So in conclusion, let me know if you have any questions. Rewatch the video or seek out another video if you need. As always, make sure to check Google Classroom to see what your task is at hand. Let me know what you need, and until next time, have a good one.